Hello students, this is lesson 2 on dimensioning drawings. So your objectives for this lesson are: 1. Use conventional dimensioning techniques to describe size and shape accurately on an engineering drawing. 2. Create and read a drawing at a specified scale. 3. Correctly place dimension lines, extension lines, angles, and notes. 4. How to dimension arcs, circles, and inclined surfaces. 5. Use standard practices for dimensioning prisms, cylinders, holes, and curves. And finally, identify guidelines for the do's and don'ts of dimensioning. Please print out the objectives because it also has some terms in there that you need to study while you're going through this presentation. Okay, understanding dimensioning. The increasing need for precision manufacturing and interchangeability of parts has shifted responsibility for size control to the design engineer or the detail drafter. So practices for dimensioning architectural and structural drawings are similar in many ways, but to those who dimension manufactured parts, some practices differ. We're primarily going to be talking about manufactured parts in this class. Refer to the following drawing standards: ASME 14.5 2000, that's dimensioning and tolerancing. Then there's also ASME Y 14.41, that's digital product definition. And then ASME B 4.2, these are standards for preferred metrics and limit fits. Okay, there are 3 aspects of good dimensioning. Techniques of dimensioning: how to put the lines on the paper, and then the placement of dimensions is very important for the readability of the drawing, and finally the choice of the dimensions. These are 3 things we need to pay attention to. Tolerances. So tolerance is one of your terms here. A tolerance is the total amount that a feature on an actual part is allowed to vary from what is specified on the drawing or the model dimension. So this one, the tolerances are specified with a single note that said all tolerances are plus or minus 0.02 inch unless otherwise specified. And then here is what they call a block tolerance. Okay, that's a note on your drawing format or your title block that specifies what the tolerances are, if the tolerances aren't stated on the drawing. Okay, so now there's 3 types of lines that are used in dimensioning: dimension lines, extension lines, and center lines. Okay, so if we look at this picture right here, we have an extension line. Extension line comes from the edge of the object, and then the dimension line is used to place the dimension between the extension lines. So a dimension line has the dimension inside of it, and the extension lines come off of a edge or of the object. The other type of lines we want to talk about is a center line. Here we have a circle with center lines going through the circle, and then that circle is located with dimensions coming off the edge of the object to the center line. Throughout this text, they talk about these different sizes. In a lot of cases, your software takes care of that, so I'm not going to get too particular about that. Here's some guidelines for using dimension and extension lines. This picture A here, that is a good practice. We have the extension lines crossing here. It's all laid out good, so there's no gaps, so it's okay. Now, in this one over here, we have dimension lines that cross extension lines. Man, that's not good practice. In this case, what we have is we didn't have the extension lines coming all the way up to the object. That's not good practice either. Here's something that we don't do either, and that's put the dimension lines within the object lines. That is not good either. And then over here, you want to use extension lines before you put these dimension lines, so that's not good. over here we're talking about how to put the lines, the extension and dimension lines on a part. This is good practice compared to this. This is not good practice. This kind of looks like a little ad hoc. It's got this one coming up this way. This one looks neat, okay, where it has all of the dimensions are on the same side of the part. And it just looks better. In this case, here is a error. See, the extension line should come from this slot here in the part, and that extension line should cross the object line here and here and here and here and here and here as well. So these are things we need to remember when we're putting dimension lines and extension lines on our drawings. Leader, what's a leader line? Okay, a leader is a thin, solid line directing attention to a note or a dimension and starting with an arrowhead or a dot. Okay, in this case here we have an arrowhead on our leader line. In this case we have a dot. So for the best appearance, make leaders near each other and parallel across as few lines as possible, and don't make leaders parallel to lines, nearby lines on the drawings. It just gets confusing. And don't make leaders go through a corner of a view, and don't allow leaders to cross each other, and don't use really long leaders, and then don't make leaders horizontal or vertical. Okay, so in this case we have a leader, it's at an angle. This one, the angle is too steep, and this is a good leader here. Okay, so those are leaders and how to construct leaders. Drawing scale and dimensioning. Many standard title blocks include a note that says do not scale drawing for dimensions. The dimensions should be on the drawing. They should be defined on the drawing. They should, your reader of the drawing should not have to put a scale on there and try to figure out what the dimensions are. That's just poor and incorrect dimensioning. Okay, I want to talk about unidirectional dimensions. Okay, this is an example of unidirectional dimensions. In unidirectional dimensioning, all dimension values and notes are lettered horizontally to be read from the bottom of the sheet as oriented by the title block. Okay, so see this 7 here, this is the same orientation as 28, the 22, and the 33. Those are unidirectional dimensions. Okay, so units. What units do we use when we put on dimensions? In some cases, we can use millimeters. In other cases, we will be using inches. It depends on the drawing that we're creating. When we're using inches, it's good to note that all measurements in inches, unless otherwise noted, is used in the title block or as a note. Also, you can have a note saying that all measurements are in millimeters. Okay. That's something to have on your title block. That's something that you would need on your title block so everybody knows what those dimensions are, what units those dimensions are. If you're using millimeter values, okay, they kind of look like this. Here's a radius R 4.1, 1.27. The millimeter is commonly used for most metric engineering drawings. 1 place millimeters are used when tolerance permit. 2 place or more place millimeter decimals may be used when higher tolerances are required. And now if we're going to be using inch dimensions, 2 place decimals are typical when tolerance permits. 3 or more places are used for tolerance limits in the thousandth of an inch. If 2 place decimals, in 2 place decimals, the second place preferably should be an even digit. I'm not going to hold you to that one, but this is how inch dimensions look on the drawing. In some cases, what you're going to want to do is have dual dimensioning and combination of units. In this scenario, what we're doing is we're showing both metric and inch units on the drawing. Okay, and how we do that, we can do it several ways. One is the position method, okay, in which case we have millimeters shown on top and then a line separating them in the inch underneath, or we'll have millimeters / inches, or a bracket method, in which case we can have a note that says dimensions in parentheses are millimeters, in which case here we have our millimeters. They actually have this one backwards. So in this case, we have millimeters on top, and then we have inch dimensions underneath. Okay, I'm going to end this movie here. We're going to pick it up again with another movie for the rest of the presentation.